Hey guys, Miss Peterson here, and today we're going to be walking through the lab analysis for part 1 of our force, mass, and acceleration lab. And as we work through this analysis, I really want you guys not to lose sight of the purpose of this lab, okay? The purpose of this lab was to find a mathematical equation that can represent the relationship between the force applied on an object, the mass of that object, and its acceleration that you get. Okay, remember the object that we were studying was our modified Atwood's machine with our hanging mass and our cart. And in part 1 of this lab, we looked at the connection between force and acceleration, while the mass of our system was kept constant. So let's go ahead and look at some data. So I have my data right here. I have the mass of my entire system in grams. I have my force and my acceleration in meters per second squared or meters per second per second. So say I wanted to convert my mass to kilograms. If you remember from our notes, a Newton is a kilogram meter per second squared. So we might want to keep all of our units consistent and use kilograms. So to convert grams to kilograms, it is the measurement in grams divided by 1,000, and that will give you your mass in kilograms, okay? And remember, Excel can do all of that math for you. A couple other quick things to remember about Excel. If your data is like not showing up, you can adjust that there. Excel does not understand letters, okay? So anytime you're working with numbers in Excel, make sure to only put your units in the headings, not with your actual numbers, because Excel does not understand units, okay? Excel is just for numbers. So I have my different forces that I collected from the force sensor, and I have my acceleration. Typically, the easiest way to start a graph, okay, because what if you might have some other data here, is to go to Insert. All of our graphs are going to be X, Y marked scatter plots. Okay, just like that. Excel knows what I'm doing. It thinks it knows what I want. So I'm going to try to move it to something where it won't automatically populate a graph for me. Nope, that's not what I wanted. Okay, click off. Okay, that's what I wanted. Just a blank graph. Okay, because then we can be super precise when selecting our data. So you go into Select Data, and we want to add a series, a sample set, to our data. Now on our X, I'll call this, it doesn't really need a name. My X values, okay, your X-axis is always going to be the variable that you changed, your manipulated variable, okay, or your independent variable, okay? Now, what did we change? Well, we moved masses from our cart to our hanging mass, and it was the force of gravity pulling down on that we changed. So our X values will be our forces, okay? Our Y values, that is our dependent variable, or our responding variable, the one that responded to the change in our force, that is our accelerations. So you just click and drag to select those. And you should get a nice scatter plot that looks something like this. My data looks pretty linear. I have one weird data point there. No big deal. Maybe it's straight, maybe it's a little funkier. That's okay. So now we need to add all of the stuff to our graph. I'm going to add my axis titles, a horizontal one. Oops, I took it off. I do want that. Oh. Don't want to take off my axes. Definitely need those. What I wanted to do is add an axis title. We put the vertical one there. We put the vertical and the horizontal. Okay, on our x-axis was our force in newtons. On our y-axis was our acceleration in meters per second or meters per second squared. And I'm going to go ahead and title it with part 1, which was force or acceleration y-axis versus force, our x-axis. Okay, so we have our data there. We have our axes labeled. Now we need to add a trend line. So a trend line is where we get all of the info. You can either add it right there in add chart elements or up here in trend line. You always want to go directly into more options. That'll bring up this thing on the bottom where you can format your line. Okay, you can look at its effects or the trend line options. I'm going to go over to the options. This data looks pretty linear, and can always check that by telling it to display the equation and the r squared value. Now, let me go ahead and zoom in on our graph so we can really focus in on it. If we look at that r squared value, it is 0.995. That's pretty good. Okay, 0.995, 0.99. That is a really good r squared value. That tells us that the linear is a good fit for our data. Okay, I wanted to talk about one other options in our trend line. So let me click back on my trend line and I'm in other options. That is the set intercept 0 function. Okay, now sometimes we check that and sometimes we don't. And you really have to think about the data that you're talking about. Set intercept equals to 0 means that when your x-axis is 0, your y-axis is also 0. Now, does that make sense for this lab? Okay, well, if our acceleration is 0, that means that there should be no force. Okay, no force, no acceleration. Yeah, that makes sense. So we will set the intercept equal to 0. That'll simplify our equation and get rid of that y-intercept. Okay, and make it so that we just have this equation there. Okay, so that is how to do the graph. Now, in your analysis, I'm going to ask you some questions. Okay, we know our r squared value is good, and we have our y-intercept with our slope and our graph of our line with y equals the slope 0.7523 times x, the force. Now, the slope, this 0.7523, we always want to figure out what that means. What does that mean? There's a couple different ways we can look at it. What I recommend is first, look and see if you can figure out the units. Okay? Remembering that a Newton is a kilogram meter per second squared, see if you could figure out what the units of that slope would be. Okay? Then, see if you can figure out what relationship those units have to some of the things we measured in our experiment. And maybe it might be related to the goal of this experiment. Okay? And that's our data analysis for part 1. Okay, cool? Okay, cool.